Let's look at the proof of the quadratic formula. So the quadratic formula is used to solve quadratic equations that equal to 0. In other words, an equation in the form ax squared plus bx plus c equals to 0, where a, b, and c are just some numbers. So we've generalized that by using letters here, and x is some unknown, where x can be any letter. So we could use y, z, or any other letter that we choose. Now, to show the proof, we're going to start with this form here, and our goal is to rearrange this to make x the subject. So right now we see that two terms have x in them, that's ax squared and bx, and so we need to first ensure that we have only one term that has x in it, and then we can go about rearranging to prove the quadratic formula. So to start off, we're going to divide each of the terms by a, which is the coefficient of x squared here. And so if we do that, we end up with x squared plus b over a multiplied by x plus c over a, and then 0 divided by a is just 0. We're now going to take away c over a from both sides. So we end up with x squared plus b over a multiplied by x, which equals to minus c over a. And now we see that we've got the two terms that have x in them on the left-hand side of the equation. So what we can do is we can complete the square, which will then result in us having one x only. So right now we have two terms that have x in them. We'll be left with one term that has x in it. And so if we complete the square, we end up with, in brackets, x plus, and so we halve the coefficient of x here. So b over a divided by 2, which is just b over 2a, and this is all squared. If we were to expand these brackets out, we would get the following. So x plus b over 2a all squared is the same as x plus b over 2a multiplied by x plus b over 2a. And so if we expand the brackets here, we get x times x, which is x squared, and then x times b over 2a, which is plus xb over 2a, and then b over 2a times x, which is plus xb over 2a, and then b over 2a times b over 2a, which gives us plus b squared over 2a times 2a, which is 4a squared. And so collecting like terms here, we end up with x squared plus 2b over 2a x plus b squared over 4a squared. And so simplifying this, we get x squared plus b over a times x plus b squared over 4a squared. And so we notice that looking at what we had on the left hand side of the equation here, we had x squared plus b over a x. And so we've got that in these first two terms, but we've also got b squared over 4a squared. And so we need to take that away from these brackets, so that when we expand these brackets out and we take away b squared over 4a squared, we end up with x squared plus b over ax. So doing that, we're going to write minus b squared over 4a squared, and then this equals to minus c over a. What we now do is we add b squared over 4a squared to both sides. So we're going to end up with x plus b over 2a all squared, which equals to, and so if we add b squared over 4a squared to both sides, I'm going to write that term first. So we have b squared over 4a squared minus c over a. We're going to make the denominators the same, and so I'm going to multiply the numerator and the denominator of this fraction by 4a. And so if we do that, we end up with x plus b over 2a all squared, which equals to, so we get b squared over 4a squared minus, so 4a times c is 4ac, and a times 4a is 4a squared. Combining these two fractions together, we end up with x plus b over 2a all squared, which equals to b squared minus 4ac all over 4a squared. So all we've done is we've combined the two fractions here. In the denominator, we end up with a squared term. So 4a squared can be written as 2a all squared. So we're now going to write that in. We have x plus b over 2a all squared, which equals to b squared minus 4ac all over 2a all squared. So 2a all squared gives us 4a squared. Now, whenever solving an equation or rearranging a formula, if we take the square root, we need to include a plus or minus. So for instance, if we had the equation x squared equals to 4, and we solve this, we would take the square root of both sides, and so we would have x equals to the square root of 4. If we didn't include plus or minus, then this would just end up being x equals to 2. But in this equation, there's two solutions to this. If x equals 2, we get 2 squared, which is equal to 4, so that's one solution. But also, minus 2 all squared will give us 4 as well. And so in fact, there are two solutions to this equation up here. Therefore, to obtain those two solutions, when we're solving an equation or rearranging a formula, we need to add a plus or minus when we take the square root. And so this would then end up giving us x equals to plus or minus 2. And so we get the two solutions here. If we took the square root of a number on its own, not in an equation, then by definition, the square root of 4 is equal to the positive value, which is 2. And so this is because we are not solving an equation, we are just taking the square root of 4 on its own. Using this logic, we get the following. So taking the square root of both sides, we end up with x plus b over 2a, so the square symbol will go, and that equals to the square root of b squared minus 4ac all over 2a all squared. Now, using a third law, we can apply the square root to both the numerator and the denominator separately. And so we end up with x plus b over 2a, which equals to the square root of b squared minus 4ac in the numerator over the square root of 2a all squared. Since this is an equation, and in the numerator we cannot simplify the square root of b squared minus 4ac any further, we add a plus or minus. However, in the denominator, 2a all squared, if we take the square root of that, then the square root symbol and the square will cancel each other out. And so we'll be left with x plus b over 2a equals to plus minus the square root of b squared minus 4ac all over 2a. Taking away b over 2a from both sides, we get x equals to minus b over 2a, and then we have plus minus the square root of b squared minus 4ac all over 2a. And so if we combine these two fractions together, we end up with x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. And so we've proved that the quadratic formula indeed is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And so we're done.